Alright, so here we have an arrow that's shot upward, and it experiences deceleration due to gravity and due to air resistance. So the differential equation is going to be dv dt equals negative 32, that's the gravity part, minus v squared over 800, which is what we're told is the air resistance part. A couple of initial conditions were given here. The initial velocity is 160 feet per second, and the initial height is 0 because it was shot from the ground. Okay, so the first thing we're going to do to solve this, we're going to factor out the negative 1 over 800. Okay, if I do that, I'd be left with a positive v squared plus 32 times 800, which is 25,600. Okay, I separate variables. I get all the v's on the left and the dt on the right, and then I integrate. Okay, now the integral of the left side here, because it's v squared plus something, partial fractions doesn't help you. This is an inverse tangent. This is going to be 1 over 160. That's the square root of 25,600. Inverse tangent of v over 160. And that's going to be equal to the integral of the right side, which is just negative 1 over 800 t plus a constant. Okay, let's go ahead and multiply both sides by 160. Okay, 160 over 800 is so this would be negative 0.2 t plus 160c is still just a constant, so I'm just going to rename that c. Okay. Now let's go ahead and do our let's figure out what that c is using the initial condition. We are told that v of 0 is 160, so that means that if I plugged in t equals 0, v would be 160, so that means the inverse tangent of 160 over 160 is equal to 0 plus c. That means c is the inverse tangent of 1, and the inverse tangent of 1 is pi over 4. Okay, so actually that c is pi over 4, and so I can plug that in. I can also get rid of the inverse tangent on the left by making it a regular tangent on the right. Okay, so that's what my equation looks like now, and then you can get v by itself by multiplying both sides by 160. Okay, so that's the velocity function. We wanted to know how high it goes, so we need to know the height function. That's the position function, x of t. That's just the integral of v of t. So that's going to be the integral of 160 tangent of negative 0.02 t plus pi over 4 dt. Let's do a little u substitution here. We'll let u equal negative 0.2 t plus pi over 4. Du would be negative 0.2 dt. So that means dt is, let's see, what's 1 over 0.2 is 5, so that would be like negative 5 du. Okay, so we've got 160, and then we'd have a negative 5 du, and then we'd also have a tangent u. Okay, so let's see, 5 times 160 is 800, so this would be negative 800, and then the integral of tangent u is the a couple ways to write it here. If you look it up, it's the natural log of secant u plus a constant. I'm going to simplify things a little bit here. That negative, I'm going to put it up into the exponent using properties of logs. So this is the same thing as 800 natural log of secant to the negative 1 power. That's the same thing as cosine. And it's cosine of u, which I'll go ahead and plug what u is, plus c. That's x of t. Okay. Now again, we can use the initial condition to figure out x of t, or figure out that constant. We know that x of 0 is 0, so that means 0 would be what, that's what you get when you plug in t equals 0. So 0 would be 800 natural log of cosine of pi over 4 plus a constant. Cosine of pi over 4 is square root of 2 over 2. So that means the constant must be negative 800 natural log of square root of 2 over 2. Okay, so you can plug that in. So here's my position function. X of t is 800 natural log of cosine of negative 0.2t plus pi over 4 minus 800 natural log of square root of 2 over 2. Okay, that's the height function. We were asked what the, how high does it go? So that's the maximum height. The maximum height occurs when, now just going back to Calc 1, the maximum occurs when the derivative is 0. So in other words, when the velocity is 0, and we already found the velocity function was up here. So that's when 160 tangent of negative 0.2t plus pi over 4 is 0. And we know that, when does the tangent function hit 0? Tangent of 0 is 0. So this is going to be 0 exactly when the thing in the parentheses is equal to 0. So that would be when t is, so it'd be pi over 4 divided by 0.2, which is the same as 5 pi over 4. Okay, 5 pi over 4, which is approximately 3.9 seconds. Okay, that's when the max height occurs, and then all you have to do is just plug that t value in to your height function to get that maximum height. So x of 5 pi over 4, let's just type that into our calculator there. Okay, it's approximately 277 feet. Okay, so that would be the maximum height. A little shortcut there actually. We didn't actually have to find this t. The velocity is 0 when this argument is 0, and so really I could have just taken this whole thing and plugged it in. So the argument of cosine would be 0. Cosine of 0 is 1. Natural log of 1 is 0. So really, the answer was just right here. It was this negative 800 natural log of square root of 2 over 2, which happens to be 277.